What we have here is some stainless steel base plate, some 309L for low carbon stainless steel filler rod. Basically, why we have 309 is it's kind of neat. Basically, if you were to have like mild steel, stainless steel, and you wanted to weld those two together, you can use a 309 rod, which basically it lets those two dissimilar metals actually bond together. So it's kind of neat to use that. And another thing is I'm welding at 100 amps. My post flow is about 15 seconds. I like having a little bit more post flow to keep a little bit of the oxides and stuff getting interfered with the welds when I'm done. It doesn't have as much color to it, and I kind of like that. I like it more silver and just DC negative, and that's it. And I don't run pulse with stainless steel. Pretty much just been taught that way, so I just like running it straight. So I'll show you how to do that now. As you can see with these Viking helmets too, the shade adjustments all inside. So like at the 100 amps I'm running, I'll just put it on a 10, basically because I had a 13 and it was pretty dark, but now I can see. And it's pretty easy to adjust instead of having to swap out shades and everything. It's right there. So here we go, I'm gonna weld it right the first time and I'll kind of show you the differences we can do. I'm going to hold that post flow on there. And there you have it. There's some stainless steel. Pretty simple. Kind of how I teach it out of my shop and how I teach it also at events with Lincoln Electric and when I'm an instructor there. What I'll first do for like beginners is I'll tell people to hold it like a pencil kind of. And you first just want to do some fusing. It's also called hytogenous welding. And you basically just take the top plate and the bottom plate and just move from right to left or whichever way your hand coordinated, right or left. And here we go. And there you go, there's some fusion. And basically with that, if it was real thin material, like sometimes people do it with gas tanks. I don't preferably like doing that with gas tanks or exhaust pipes because you want that filler metal to create a stronger bond, and that's basically why we use it, so it's stronger. And with that, the fusing's good for art stuff, and you know, I know working with Lincoln Electric, we like just really using it for art. I know a lot of people out there that don't do fusion, so it's really preferred to the person, but I know for me, I like doing exactly what's recommended and what's going to be stronger. So this is just really good practice, I say, to get used with this hand. It's kind of like driving a standard car. If you start with automatic, it's kind of like a MIG welder. You just hit the gas and go, and that's kind of how it is when you MIG weld. But with this, you have a foot pedal, you have a torch, and then you have the filler, so it's kind of just like a clutch, the shifter, and then you have the gas. So it's kind of everything you're doing. So with this, you take the same technique. You're gonna move your hand the same way, and you're just gonna dab every so often, and you don't want to do too few at times because then your diamonds get too far apart and you're almost fusing again. So you just want to add just enough filler to it. So we start the puddle, and then we get it good enough puddle that then we just start adding the filler. And we just move along with it, nice and smoothly and consistently. And there you have it. A good key note is usually when you have something that's 1/8 of an inch and it's regular steel, if you were to get calipers, 1/8 of an inch is 0.125, so that'd be 125 amps. When you weld with stainless, you're about 25 to 50% lower in heat, and as I said in the beginning of this, you're basically going to run this at about 100 amps, which is about 25-50% lower. So that's what I would do with that. And if I were doing aluminum, I go 20 to 50% hotter. That's just a good note to use, but usually you start with the steel and then you kind of base that off for where you're going to be at with stainless steel and aluminum.